So let's learn electronics. Let's understand what electronics is. So electronics is just the flow of electricity through electronic components like different devices, capacitors, resistors, diodes, transistors, you name them. These are all electronic components. Now, when you look at electronics works better with what we call direct current. So the electricity is going to be constant. Right? This is what electronics requires, any electronic component. They need a direct and constant feed of electricity. Even though some devices might need higher current than others, these are where some of the components like capacitors and resistors and diodes, they come into play to regulate that. We're not going to go too deep into how these things function, but we're going to start with the very basics. Another form of electricity we have is what we call the alternating current. It's in a nice sine wave like that. With this, what it means that any device that is connected on it is going to go on and off, and on and off. So the electricity, the wave cycle keeps changing. And you cannot use that for most of these components. So imagine you sitting behind the monitor and you're trying to use it and the monitor goes on, off, and you're trying to stare at that. It doesn't work like that. So for electronic devices, we need to make sure that we have a direct flow of electricity. So what we ended up doing before we end up using most of these electronic components that you guys are going to see on this board, we should be able to convert that power using something like this. So this is a transformer, and this is a power supply. So this does all the rectification for us. This steps down the voltage to an acceptable volt, and then this will do the rectification. So we're going to talk about how to convert AC voltage to DC voltage, and we'll talk about a few things. So like I said, from hydro, from the main power source, because we're here in Canada, typically our voltage runs at 110 volts. So I'd say maybe from 100 to 120 volts AC. Ideally, it's always going to be at 110. So those of you who are in other countries like Africa, some areas in the United Kingdom, in Europe, like the United Kingdom, etc., you guys would be using things like 220 volts AC, and it fluctuates. Right? Sometimes it will drop to maybe 210. It would go as high as 240. So what we use to step down to reduce this voltage, because we're dealing with low voltage, we want to be able to transform this high voltage from 110 or 120, we want to drop it all the way down to at least 16.5 volts AC or 24 volts AC. So let's look at how we do this.
Some guys are saying Uganda 220 volts.
Yes, so Uganda is 220, right? Perfect.
Kenya 240.
So Kenya is 240.
Gambia 220.
So it keeps fluctuating based on where you are. So now look at it. Because we live here in Canada, and I decided to buy a laptop, and the charger that came with a laptop is rated as 110. Even though the manufacturers are getting smarter and smarter every day, some of the adapters, the power adapters that you would get, like this one, this outlet supports anything from 100 volts AC all the way to 240 volts AC. Meaning that when I take this and I plug it into a 110 voltage outlet, there is a device in there that's able to tolerate that voltage. If I take it and I come to Gambia or I come to Uganda, for example, where it's 240, and I plug this in, this is still going to work. So this has a voltage ratings all the way from 110 or 100 volts all the way to 240. One way as a professional for you to know is anytime you look on these, we're going to try and also show this down the road, you should be looking for the input voltage versus the output voltage on this. You can see there's lots of writings on that. And with me now, I need to use glasses to be able to see. Or I take my phone and I try and magnify the writings on it. If it only says 110, then meaning that if I brought this, or I had a brother in Uganda who said, can you buy me a laptop? And I bought the laptop, and the laptop only said 110. What I needed to buy in addition to this was what we called a step-up transformer or a step-down transformer, depending on where you are. Now, from here, if I'm sending the laptop to him in Uganda, now remember that in North America it's 110, but when it gets here, it's going to be 240. But this has only been designed for 210. So what is going to happen? He's going to receive the laptop in Uganda, and he's going to be so excited. And in the quest to have it working, he's going to plug it into this 240, and that's a high voltage. Right away, he's damaged this, and the laptop is not going to work because he just destroyed the components in it. So it is better that you get what we call a step down transformer. So this step down transformer, because Uganda uses that, and this is from Canada, it's going to step the voltage from 240 all the way to 110 volts AC. So one part of the transformer is going to be plugged into the outlet in Uganda, and the other part of the outlet is going to be plugged in here. So this begins to receive a safe voltage to operate. The downside though is anywhere he has to go within Uganda with his laptop, he has to carry that step down transformer with him. If he doesn't and he plugs it, he's going to end up damaging this. So transformers, they work on what we call the 10 ratio. So transformer works on what we call the 10 ratio. If N, I say N1, N2 is the ratio. So if I increase here 3 times, let's go back. Let's say if the 10 ratio is 10 times. So anything I do here, if I make 10 coils here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 coils. What is going to happen here is it's going to amplify it 10 times. So here it's going to be 100 coils. That's just what is going to happen. So if whatever I plug in here, I plug in, let's say, 120 volts in here, and it gives me 20 volts. I put 100 in here, I get 20. What happens if this goes to 240? Then this, because I've doubled this number, this is also going to end up doubling. So this becomes 40 volts AC. If I end up dropping the input from here to 60, then this is going to drop to 10. That's just how transformers work. So even though you might find a transformer like this, that is rated for 16.5 volts AC, it depends on how much I'm putting in at the primary coil. So now that we understand how transformers work, let's see how to convert AC to DC. Well, so to do that, we have what we call a diode. And the diode is a gatekeeper. It allows current to only flow in one direction. And it's symbolized by this. Right? And that's just what it is. It allows current to flow in here. This is the anode, and this is the cathode. Cathode is the negative portion. Here's the, so electricity always flows from here and comes out from here. If you want the electricity to come like this, this is going to block it. It's a gatekeeper. So think about a diode as this. So you have a pipe, right? And the pipe has this that is here. And it has this stopper here. So that's your pipe. So you have water coming out through here. Once the water gets here, it's able to lift this flap up like that. So this can open like that, can open like that. So this is a flap. You can open it like this. But if you try to force it all the way back, because of this stopper here, this cannot swing all the way here. It just allows electricity to flow. That's just pretty much how a diode works. So you can either do a half wave rectification, or you can do a full wave rectification. Full wave meaning that you are rectifying the entire wave cycles. And how do you do that? We are able to take a bunch of these diodes and connect them in a sequence whereby we're able to filter the positive wave cycle and the negative wave cycle. So let's take a look at that. So having in mind that we are able to use what we call the diode, we are going to arrange them in what we call a bridge format. So I take one and I draw it like that. Yes. So let's look at this. So I have here the cathodes, the anodes. I have the anodes here and I have the cathodes here. Now when you look at here, I have one cathode and one anode. It doesn't really matter how you arrange them. You just have to make sure that at two of the points you have the anodes, the cathodes together, and two of the other ends you have the anode together. Right? So you can decide to do this. Oops. Yeah. Yeah, this, right. Okay, so you could decide that you could arrange them like this. Still doesn't matter. You could also arrange it like this. Really doesn't matter how you just need to know where your inputs are coming and where your outputs are also going. That's just all you need. So now let's take a look. This is what you have. You have your AC wave cycle coming in. When you look at this, this is the positive cycle of the wave. This is the negative cycle of the wave. And it keeps alternating. That's why we call it alternating. So now when I take this wave cycle that keeps alternating, and I end up connecting it here, let's look at what is going to happen. I have all the positive side. Remember, when it hits here, the positive side of the wave cycle, once it gets here, this is going to block it. It's not going to allow voltage to go here. No. But it's going to allow voltage to go here. The positive side of the wave to come from here. Right? That's just what it does. And so I'm going to take, because I'm doing the full wave rectification, you have the same cycle coming up from here as well. When you have the waves connected to here, the AC, once this gets here, it's not going to allow the positive wave cycle to go here, the top here, not here. It's going to allow the positives to come here. So we have the positives here and the positives coming through here. So what are we going to do? We're going to get like this. These are all the positive wave cycles that has been able to allow to flow through here. And then the negative portions of the waves, when they get here, this is going to allow negative to go through. Here is also going to allow negative to go through. So when we get here, this is what we're also going to get. So I've been able to take the positive and the negatives. I've separated this waveform, right? That's just what it is. But we know very well that this is not smooth enough for us because of the way it's pulsating. And this is where what we call a capacitor comes in. A capacitor is like a battery bank. It stores charges and it stores electricity, and it would release that electricity when we need them. So here, what we're going to do is we're going to connect a capacitor here between the two of them. So with these wave formats, it's going to end up charging this capacitor here. And every time it goes up, it charges. When it's about to discharge and come all the way down, the capacitor fills it in and says, nope, I got the charge, here it is. So what we're going to end up from here, after we've connected the capacitor, is we're going to have this. So anytime it tries to discharge, the capacitor fills it in. So we're going to have near straight. And when you look here too, it's going to behave the same thing. And that's how we're able to have the positive and the negative voltages being rectified by that. However, this is not as smooth as possible, but you can still work with it. At the point where you have to now make it very smooth and straight, that is where you have things like putting in a transistor, putting in a resistor, putting in other electronic components to make it very smooth. But in the nutshell, this is just what happens. By connecting 4 diodes together in a bridge to filter the wave, the positive and the negative wave cycles that is coming out from this transformer. And definitely, remember that I said we have the primary side, which is 110 volts, and we have the secondary, that is 16.5. So what I'm doing here is 16.5 volts AC. After doing that, what I'm going to have here, I'm going to have 16.5 volts DC. So this is going to be my positive 16.5 and that. Sometimes there are few losses in here. But you can take this and you can do so many things with it. And that's what they've done here. So when we look closely on this electronic board, you'd notice one thing that is here. We have the diodes on this component. So this is 1, 2, 3, 4. They have those 4 diodes that are going to do the rectification. And obviously we have a capacitor in here. And this capacitor is what is going to do the filtration and also provide an active source. They have a resistor and they have other components on here to do the filtration, and you get a very smooth voltage. This power supply that I have here is the SMP3. It's made by a company called Altronics. And Altronics, when they bring it in here, they have some dip switches that you can have either a 6 volts, 12 volts, or 24 volts out of this power supply. So in the nutshell, that is what we have to do. Having this knowledge in mind now, we have positive and we have negative. So the power supply we're going to be moving on, that we're going to be using, comprises of a positive and a negative for all the electronic devices that we have. So let's talk about switches, and let's talk about poles and throws. We use that a lot when it comes to electronic components, like just this basic switch. When I come here and I turn this on, the light goes off. When I do it again, the light comes on. We use a lot of these in electronic components a lot. And what are they? So a switch is just a device that would make or break the circuit, the electrons that are flowing through an electronic component. So for example, let's say I have a lamp here. And I have my power source, right? Now, if I connect it like this, I'm going to have constant flow of electricity that is going through this lamp. And the lamp is always going to be on. The only time the lamp is going to go off is either the power source runs out or this bulb is damaged. And it's not always that we need this lamp to be on. So what we can do is we can introduce what we called a switch. And I put a switch here. So what this switch is doing now is, even though this battery is fully charged and this lamp is fully working, by opening up this switch, it does not allow electricity to flow through because it's not complete here. And this is what we're going to be talking about, this device here. They come in different stages. You could have a switch that is like this. And you could have another switch that is always going to be like this. So in this state, one of the pins is going to be a common terminal, and one of them is going to be either in the open or the closed state. Now, when you look at this and you look at that, you see this is already open. So when I bring electricity from here, this electricity cannot continue to flow from here because of the bridge, because of the open space. But look at this. When I introduce electricity here, because these two are touching, that electricity flows and I get that voltage out from here. But in this situation, the electricity just stays here. So I cannot accomplish that electricity from going in here. So if we understand that, the only time that I can let electricity to flow through is I have to force this to touch that. And that electricity from here is going to be transferred on here and come out. In that case, we call this a normally open switch. And we call this one a normally closed switch, because that's how it's going to come from the factory. And this is going to be your common terminal. It doesn't matter. I can either say this is my common terminal and say this is my normally closed, because it's just a two-way switch. Or I can say this one also is my common terminal and this is going to be my normally open. It really doesn't matter. It's just a switch. I can bring the electricity from here. It's going to be waiting here. The only time this electricity is going to be transferred to come out from here is I have to force this to touch that. But with this, when I introduce the electricity from here, right away I'm going to see it here. So if we can understand that, that works. When it comes to electronics, there is a name for this type of switch. What is the name for this? Who knows what it's called? In terms of the form. Can someone, do you think someone can answer? So we have forms of relay. Who knows? Who can tell me what this form of relay is? The first one. Anything come up? Okay. So in electronics, we have names for these. This, think about it like this.
Somebody called parallel?
Yes? Someone said parallel?
Yeah.
Okay. No, that's not a correct answer. In electronics,
Normally open?
okay, normally open is it, but there's a form that we call it. We have a form A, form B, form C. Look at it like this. We have a form A, B, and C. These are different types of switches we have. A form A, a form B, or a form C. Now let's look at this one and how easy it is for you to remember the type of relay this is. Let me get rid of this guy here. So when you look at the alphabet A, you see there's an open between here, these two terminals. When you look at B, it's all closed. There is no opening on there. And then we have C. So when you look at this switch and that switch at the terminals, which one is open and which one is closed? Definitely this one is open, right? So this is a form A switch, this. So any switch in the normally open state is called a form A. And when you look at this, B is closed. This switch is closed because they're both touching. So definitely this is a form B switch. That's what this is called. And any switch that you have an A and a B put together is called a form C. So what are those type of switches? This is a typical type of a form C switch. So it's a switch that has so let's look at it. This is your common terminal. You have this open, which is this open here. And you have this closed, which is this closed. So this becomes your normally closed. This becomes your normally open. And this becomes the common. So this is a form C switch. So that's how a form C switch looks like. Meaning that any voltage that I introduce here, anything that I put here, is automatically going to come out from here and not there. Right? The only time that I want this electricity to show up here is this has to switch like that. For those of you who've seen the railman, you know the trains, right? When the train is coming and it has to switch. So sometimes you can have a train. For those of you who've had that opportunity to see the train, and I don't know how they call that guy. Is it the train master or whatever it is? You have one train track like this. But one of the rails is going to go here and make a right. And you have another one that is going to go here. So the train is coming. Once the train gets here, it's up to the station, the guy who is here. There's always sometimes there's a booth here that there's a guy sitting in. And he will get down and come here. There's a lever. He's going to hold that lever and pull it. If he pulls it down, this track switches a little bit to make contact with that. And then when the train drives, it's going to go here. If the next train gets here and it wants to go left, then he has to pull it the opposite way. And this is going to make contact with this so that the train can go here. So the guy who is here, he is the one directing the path of the trains. In electricity or in electronics, a relay is what does that. And the thing responsible for switching the electricity between the two terminals is called the pole. So this here is called pole, and these two terminals here are called throws. So these two terminals, that is what these are called. This is the pole. So this pole switches between these two terminals like that. So we call this a pole and we call this a throw. Now let's see how we can call this form C type of switch. When you look at it, you have only one pole. But this one pole is switching between two throws. One of the throw is a normally open, the next is a normally closed. So we can call this a single pole, but it's got two throws. So a double throw. That is how this type of switch gets its name. A single pole, double throw. Now that we have this in mind, let's look at this. I'm going to need your help to try and tell me what the name of this one is, for those of you who are watching. So I have this. And I have this. This is the common, this is a common, and I have a connecting rod connecting this. So this is the normally closed, normally open. This is the normally closed, this is the normally open. Are you able to tell me what this is? Now let's look at this. This pole that is here can only touch this or that. So when I switch it here, it can only touch this. This does not touch that. And this cannot touch this. In the same way, this pole cannot touch this and cannot touch this. All right? So whatever I introduce here, I could decide to introduce here 12 volts DC. But on this side, I can decide to introduce here 36 volts DC. So what we're going to see is the 12 volts that I just introduced at this common terminal is going to show up here, 12 volts DC. And the 36 volts that I just introduced here is going to show up here as 36 volts DC. Right? Two separate voltages. 36 here, it showed up there. 12, it showed up here. How do I call this type of switch? Any ideas?
So two of them commented
Yeah.
double pull, double through.
Double pull, double through, and that's correct. So let's understand why that's a...
40 commented double pull, double through.
Oh, 40?
Yeah.
Big shout out to you, 40. 40 from, I think he's making the Gambians proud, right?
One more guy called Cole.
Cool.
He also commented double pull, double through.
Okay, so I think 40 is from Guinea, and he's from Gambia, right? Yes, okay, perfect. So now for those of you who don't understand how they said it's a double pull, double throw, let's try and understand it. Now look at this one. On here, how many poles do we have? We have one pole here, and we have another pole here. Remember, they're all connected with a rod. Think about it like the wiper in front of the car. When you turn the wiper on, they both move like this. That's what happens. So that is how this is going to work, like this. So you are able to move this to connect to this, like this. And this is also going to move here like that. So when you create an action, then you switch both of them like this. But when you look closely, you have one pole here, and you have another pole here. So in total, how many poles do we have? We have 2 poles. So we have 2 poles, we call it a double. Double, or you can say 2 poles. Double pole. So they're the same. Now, how many throws do we have in the system? We don't have 4 throws. Because if we had 4 throws, meaning that this pole could touch here, could touch here, could touch here, and could touch here. But that's not the case. This can only touch here and here, and that's it. This can only touch here and here. So that makes it how many throws? We have only 2 throws. Because remember, they're both moving together. So it makes it 2 throws. And that is why we have 2 throws. Double throw. So anytime you see a switch like this, you should be able to tell me whether it's a single pole with 2 throws, or 2 poles with 2 throws. That is how we get the name. All right, are we all good? Perfect. Now that we understand how this works, it takes us into another one. Okay, so someone might be asking, what if we have this too? You can have multiple of them. Someone might be thinking, okay, what do we do when we have this? I'm going to get you to tell me. So we have the common, 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 and then we have this. This is the normally closed, normally open, normally closed, normally open, normally closed, normally open. Can you tell me what type of switch this is? Just based on the knowledge that we had. Remember, this pole here can only touch these two terminals. And this one can only touch this and that. This is touching only these two. This is making contact here. This is making only contact with this and that. So when you look at it, they're all connected to the same arm. So how do we call this?
A lot of comments.
Okay, let's see.
Somebody said single pole, triple throw.
So someone said single pole, 3 throws.
Somebody said SPBT.
SPBT.
Somebody said 3-pole double.
3-pole double throw.
Somebody said multi-pole, multi-throws. Somebody said that. Triple pole double throw as well, somebody said.
Double throw, yes?
Yeah, triple pole double throw.
Triple pole double throw. Okay, so let's look at it. Now, how many throws do we have in this circuit? Remember, this is unique. This is unique. This is unique. The reason why we have things like this is we are able to send different voltages on that. Now here, we have how many poles? We have 1 pole here, 2 poles, 3 poles. So we have 3 poles. How many throws do we have? We have 1 here. It's just 1, right? We have another one. So this is 2 throws. This is 2 throws. This is 2 throws. Remember when we had this one here like this. We call this a single pole double throw because we just had these 2 throws. Only 2. 2 throws here. So when you look here, the throws do not change. The throw still remains 2, right? So we have 3. So we have 3 poles, double throw, and so on. You can have 4, 5, 6, 7, etc. What goes on here is when you have a situation like this, because they all move together. Think about it, a tractor trailer. Sometimes a tractor trailer needs 3 wiper blades to go back and forth. So what is happening here is I can decide to put 12 volts here. And I can decide to put 24 volts here. And I can decide to put 38 volts here. So whatever device I'll connect to this end of the switch only requires 12 volts. Whatever I'm going to connect on here requires 24 volts. And whatever I'm going to connect on here requires 38 volts. So this time, when there is an action, I want, if it's a light bulb that I have connected here, and there is a fan that I have connected here, and there is, let's say, a siren that I have connected here. What is happening here is, in this state, the siren is going to be blurring. The light, this is fan, and this is light. The light, because the light is not receiving any voltage, the light is going to be off. The fan is not receiving any voltage, the fan is going to be off. But the siren is receiving voltage, so the siren is going to be on. However, if we switch it like this, what is going to happen? Now the light is going to receive voltage, so the light is going to turn on. The fan is going to receive voltage, so the fan is going to turn on. And when I come here, I've taken the voltage, electricity away from the siren and brought it here. So what is going to happen to the siren? The siren is going to go off. So I can control 3 different equipment using 3 different voltages on this type of relay. Now that we understand this, there is another thing that we want to talk about, which is momentary and maintained. So all the switches that we spoke about, the one that is like this, the one that is like this, and this one. All these type of switches, this is what? A normally closed switch or a form B switch. This is a normally open switch or a form A switch. And this is a normally open, normally closed switch. So it's a form. So this is going to be NONC. It's going to be a form C switch. We could have all these switches in either a momentary or a maintained state. What do I mean by maintained state? So let's look closely here. Or I can even use this. Oh. I almost cut myself, eh? There was that thing here. I have to tell Marak to grind it down a little bit. Let's look here. You see this switch? When I come in the morning and I press this switch, the light turns on and I can walk away. Whilst I walk away, the switch is going to remain in that state and the light is going to be always on. Meaning that when I force this to touch that, now it's going to stay where it's supposed to stay. If I'm able to push this and it stays there, then that is what we call a maintained switch, because it's going to maintain that integrity or that state until I come back and I come and toggle that switch. When I toggle that switch, then it's going to go off, right? That is a maintained switch. We have other switches like that, that when I come and I press the button, like this. If I do this, the light is going to go off like this, but my hand is still on it. The moment I take my finger off, the light comes back on. In that situation, we call that a momentary switch, because it happens in the moment. When I touch, it's going to change the action. When I take my hands off, that action is going to return to its default state. So let's take a look at it. We have a couple of them here. Let's look closely on this one. We have 2 identical switches here.
Like doorbell?
Yes, like the doorbell you have at your home. You know the ding dong. Once you get to your home and you press it once, it just gives you a ding dong and that's it. But let's look at this here. When I look at these 2 switches, they are identical. Right, these 2, they're very much identical. One of them, look at the first one here. When I press it, it's going to stay. It's going to stay in that state. And it's going to forever remain like this until I come back and I change it. So this is what we call a maintained switch. Now let's look at the same one here. I'm going to press it. You see, it's changed the state. But once I take my finger off, it goes back. When I press it again, it changes. So long as my finger is on it, it's going to remain in this state. But once I take my finger off, it goes back. So this is a momentary, this is a maintained. And they have its place. You could also see we have different types of switches that are here. And they come in momentary and maintained as well. So when I push it, it stays. When I push it back again, it comes back out. So maintained, momentary. What happens if you go and you do not know how to check to see if it's a momentary or a maintained? This is where you use, can you pass me the digital multimeter from the back? This is where you have to use something like a digital multimeter. And this digital multimeter is going to tell you whether it's in the momentary or the maintained state. If you have a digital multimeter that has the buzzing feature, that's going to help you a lot. Buzzing feature means if I touch both of them like this, I'm going to hear that buzz. If I take it off, it's gone. If I touch again, it's just telling me by touching these two that the loop is complete. And what do I have to do? I have to set it on, I have to put it on the setting that has this symbol. This is ohms. So that's where I got to put this. If I'm testing for continuity.
Is maintained switch same as the hold and contact switch?
The hold contact switch, yes. Because it holds it in its place till you toggle it again. So if you're testing for continuity, you put it on ohms. This is where there is no electricity flowing through the system. If there's electricity flowing and you put it here, you're going to damage this. So let's be very clear. If you're testing for continuity, no electricity has to flow through the system. Okay, so now that we have this, what I'm going to do is, let's assume this is one end of my switch and this is the other terminal. Let me just try and draw something that looks like this here. So you see the switch that we were looking at, the first one, the white one that had the momentary and maintained, it looked something like this. This is off, and this is on. So that's just how it looked like. Let me just draw it again. My drawing sucks, but it's fine. So we do this. And we have that, that's how it looks like. And we have this. It's off. And then we have on. Yes. So you have it like this. But behind this, we have one terminal and we have two terminals. One of the terminal is what we call the normally open and normally closed. And this is going to be common. So on that switch, it's a single pole double throw. That is what it is. So if I want to see whether it's a maintained switch or a momentary switch, I'm going to set it on there. I'm going to take one of the terminals on my digital multimeter. And what I'm going to do is I'm going to touch one of the common terminals. So by touching this, I'm going to also take this and touch the pin that is normally closed. So if I touch these two, because it's in the off state, we remember that in the default state, when I put something here, I should see it over there. This is a closed circuit. So if I touch here and I touch here, I should hear this sound. However, if I touch here and I touch here, I shouldn't get anything because this is the open portion of here. So on the normally open, nothing. On the normally closed and the common, I should get this. In the default state, which is off. Now, when I toggle this on, and I touch this, and I touch this, I should hear this state. Meaning that now this switch looks like this. Now, So now when in this state, when I touch here and I touch here, what I'm supposed to hear is this. When I touch here and here, there should be no sound because this is open. However, when I come here, because it's off, this and this should give me no sound. This and this should give me a sound. And so long as I do not touch these terminals, and I always continue to get a beep, non-stop beep from here, it just goes to tell me this is a maintained switch. However, when I push this down and I'm holding onto it, and I get a reading, or I get a beep from here, I get a beep from here, then it's just going to tell me, so long as my finger remains on it, so long as my finger remains on this button, and I'm getting a continuous beep from here, but the moment I take my finger off, the beep goes away, then it tells me it's a momentary type of switch. So let's demonstrate it here. These are a few that we do have on here. So let's take a look at what we have on this board. I think, did we have one of the baskets here? So that way I can show it up properly. I'll just take from here. We have one here.
240 people in, so let's ask them where they're watching.
Oh, how many people?
240.
Oh, we have 240 people watching. Okay. Yeah. So I've just been told that there are about 240 people watching us now. It would be very interesting to let me know where you guys are watching us from and if my teaching makes sense. If you're really learning a lot, let me know. If you're learning something good, it's very important to let me know that it makes sense and it's helping you a lot, and we can continue to do things like this. So on the table here, I have different types of switches, right? You find this one, and you have this one, and you have that one, and you have this one as well. So let's look at what the difference is between all these ones. So I'm going to, first of all, take this one. And in order to help me do it, because I only have two hands, unless I get Ajun to help me. So I'm going to use what we call, just going to borrow from here. Yeah, you can come and help. So you guys say hi to Ajun, because he's the one who's been making all this live work and all the posts and everything. So you guys say a big thank you, big shout out to Ajun. We make it work. Okay, so Ajun is going to help me demonstrate this. So we have this on the continuity. So you're going to hold these two for me. And first of all, to start, I have to put this on the ohms. And the ohms, remember, there is no electricity flowing through here. I want to determine whether this switch is an open switch or it's a closed switch. In most of the times, they might tell you use a form A switch. So it's up to you to determine whether this is a form A switch or a form B switch. Always look at it in the default state. This is the default state that it comes from the factory. So Ajun is going to hold this, but to help us to continue, I'm using what we call the connectors, the splice connectors. See, this guy never learned anything. He just learned it by sitting in class, watching, doing videos and editing. So now he's even telling me what the name is, splice connectors. So he's going to put two splice connectors on both ends. What that is going to help me do, put this one on the other end, is to be hands-free so that we can demonstrate. So he's put the splice connectors on, and we're going to put these on both ends. So now we are hands-free. So at this point, Ajun can hold this, and we're going to demonstrate. So this is what we have now. This is an open line. We don't hear no beep. So Ajun is going to go ahead and press. Now we get a beep. Once he takes his thumb off, what happened? The beep went away. So can you tell us what this switch is? You guys hold on a second. Maybe one of you is trying to reach out to us. Delmi training, Roland speaking. Okay, person went away. So you guys, can you tell me what type of switch we just tested here? It's connected, there is no beep. So the first sign is there is no beep. So because there is no beep, Roland speaking. Good, how are you? Yeah, we're on live right now. Yeah, we should be done in the next 10 to 15 minutes. Do you mind leaving your number so I can call you right after the live session? Hello? Okay. Hold on a second. I'm going to transfer the call to the phone. So transfer. Can you tell Pooja to take it? Hello?
Hello, this is Abdullah.
Yes, Abdullah.
So I'm calling. I need to get the information about. So right now I come to newcomers here. I've been like 1 year ago.
Abdullah, if you don't mind, if you can call me after the live session, I'll take your number and I'll call you back.
Okay. Because I'm right now in your live.
Oh, okay. Oh, you're watching the live. So, okay. So let's finish this.
I want to know where are you from?
We have about 200 and something people on the line, so we don't want to disrupt them, and I don't want your conversation to be on live. So, leave your number. What is your number?
This is my number.
Okay. Okay, I'll call you right after. Thank you. Bye-bye. Guys, sorry about that. We get lots of calls, but respectfully, we want to be able to help and support each and everyone because we are a community that want to learn. So let's get back here and try and understand. I have this. Oh. So let's get back here and try and understand. I have this. Where is this? The volume was off on. Yep. Okay, so let's look at this. Let's get back to this. Everything is connected, but nothing is happening. The only time I press this is when something happens. But when I take my finger off, it goes away. So this just, first of all, just by looking at this in the default state, even though it's connected and there is no beep, when I come here and I look at these two switches, which one is it? It's this one because it's open, right? So this is a Form A switch. But is it a momentary or a maintained? It's momentary because when I take my finger off, the sound goes away. So this one here that we're working with is a Form A momentary switch. That's just what it is. It's not too difficult. Now I'm going to take another one that we have in here. This is another one here. So we are going to look at what type of switch this one also is. So I'm just going to take this one off and connect this one. So same thing. See, there's no beep. So this is also a momentary Form A switch. We had another one in here that I guess one of that. Okay, so what we're going to do is we're going to use this one one of these ones here. So what I'm going to do is I'm going to connect. See, we have a switch here that looks identical like this. So I'm going to connect two splice connectors on here. Right, this is what we're using. And I'm going to connect this and that. So I still have that end here. Look at that. The beep is still going on. I haven't done anything. When I push it again, it stops. So this is just telling me that this is the default state as it came out of the factory. This was extended out. So this is the default state. So this state is a form A, but it's a maintained switch. Because like this is off, but when I press it, it's going to maintain that state. So this is a form A maintained switch. Similar to this, form A, but this time it's maintained. That's just how you are able to distinguish the different types of switches. I hope you guys understand. It is very, very easy. In the same time, when we look at these ones, this has an on-off. It's your typical switch. It looks like these ones, on-off. So these are also on-off switches. They make or break. So the default state from the factory is in the off state. Just meaning that this is an open switch, but when you toggle it, it's going to close and it's going to remain in the maintained state. So that's it. Now let's look at two types of switches that we have here. So these two, we call these the rocker switches, but these come in the on, off, on state. This is how the switches look like. And they got these pins. This is the off state. This is the on state. This is the on state. So this is also a switch that allows you to have two on and off states. So you can also have them in a momentary or a maintained state. When I look at this one, when I press this down, it stays in that state. So this is going to be on from here. If I press it again, it's going to go to the off state, and there's going to be no flow of electricity through it. When I press it again, it gives me an on state. So I have an on, off, on type of circuit. So when I press this, it's going to allow electricity to flow through whatever device and not here. When I press it and it comes here in this state, it gets into the off state. And then when I toggle it again, it comes here. This is the maintained version of it. Let's look at this other one. This other one here, look, when I press it, it's going to be there. But so long as I take my finger off, it's going to go back into the off state. And we use a lot of these in, like, you know, when you sit in your car and you want to recline your seat. Yeah, this is how they look like. Right. This is a double pole, double throw of it because it's got all these ones. It's got 6 pins, but you can have them in the singles as well. You know, most of the times you sit in your car and you want to recline the seat a little bit, or you want to move the seat back and forth. Most of them, they use these type. So you press, once you get to wherever you want, you take your hands off and you stop. So that is the difference between momentary and maintained. So let's recap what we did today. Today we learned about the bridge rectification. We learned about transformers. We learned about the different types of switches that we have, the single pole, single throw, single pole, double throw, double pole, double throw. We also learned about the maintained switches and the momentary switches, right? So having learned all these, we're going to move on to the next step tomorrow when we convene here again to understand how these switches work. This time, we are calling all these switches that we learned here today, all these ones, we are calling them mechanical switches. Mechanical because you have to physically press them and make them work. We are going to learn about electromechanical switches. Some will call them relays. Electro means electricity. So how to use electricity to turn the switches on and off. So that's what we're going to be learning tomorrow.
Same time, somebody's asking same time.
Same time, don't be late for class. Right? Don't be late for class. And this is why it's very important to turn your notification on so that as soon as we fire it up, you guys are the first ones to get the notifications.
And we put our links on LinkedIn and Facebook as well.
Yes, we put the links. What we're trying to do is we're trying to grow this community as much as possible. If you think you found this very informative, just share our videos. We have a lot of videos on LinkedIn, but most of the time we have a lot of videos on YouTube as well. So this session that we just did, Ajun did record it on the other one. If you think one of your colleagues or one of your friends would have found this helpful, or we spoke about something and you were not sure, we're going to post it on YouTube. So go on YouTube and you can rewatch it again. Whilst you are there, just give us a like, comment, share the videos. This is how you can pay us back, right? We want to thank each and every one of you. If you have questions, I'm going to spend 5 minutes at answering all the questions, and after that, at 5:15, we're going to bring the class to a close.
Explain the transient of the switch and the use of 10 NF capacitor or RC snubber.
So you're talking about how to use capacitors and what else? What was the question?
So the exact question he asked was, explain the transient of switch and use of 10 NF capacitor or
10 microfarad capacitor and what else?
Or RC snubber.
Okay, so no, we're not treating that as part of this class. I just want to make sure because we have a lot of people following and I want to go step by step. So let's try and answer questions regarding what we did today so that I know there are a lot of new people following because the feedback that I get is, I'm new to the space. I don't know what to do. I'm not in this country. So I'll be able to discuss that with you privately. If it's something that you really need urgent, I can definitely hook up with you. But I just want to make sure that what we thought today, if there's no clarity on it for somebody, I'd be able to address that. And we're going to go in steps, right?
Can I have 2 3-prong rocker switch control 1 12-volt LED?
So what are you talking about? You have how many prongs?
2 3-prong.
So now we learned the proper terminologies, right? So let's use the proper terminologies. Are you talking about a single pole, double throw, a single pole, single throw, double pole, double throw? We learned about this. So which one are you talking about? When we all understand the definitions and how to use the terminologies, it makes everyone's work easier. Because when you say it and I think about something else, and I use that, I might get a different result. But these are industry standard terminologies. So if we can, based on what I went through today, are you able to select which of the ones you're talking about? Just so that everybody understands. Remember, in this community, we're all from diverse backgrounds, but we are learning something for unification. So if you're asking questions and you can use the right terminologies, if you say a single pole, double throw, everyone, I would say most who are in this class today understands what a single pole double throw is. It's just going to be something like this. So if you say that, at least the community understands it. Or it's just going to be a switch that looks like this. Off. And it's got a common. And it's got 2 poles here, normally closed and normally open. So this could be that, right? So just use the right terminologies. If it's a Single pole, single throw, for example, it could be either this. So this is normally closed, common. Or it could be this. So this is a normally open, this is a common. So single pole, single throw could be any of these. And when you draw your circuit, it could also be like this. Off. And it's just going to have one and going to have one. So common, this could be either a normally open or it could be a closed, depending on what. So which of the circuits are you talking about? Did he answer?
Not really. So he said like he was late in the class. So.
Oh, you were late in the class. So we went through this, and it's going to be good for you later on to go to our YouTube channel, go and subscribe to it, because I believe that we went step by step to explain how all these switches work. So by watching that video on YouTube, you would be able to have answers to it. If not, same time, tomorrow we're going to be continuing from them. Make sure you're not late. And we're going to be going into details to the extent that we start to connect one of these ones here, which is we're going to start with one of these. We're going to start with this electromechanical relay, and then we're going to go to one of these, and then go through one with the timer. So we're going to talk about all these components and how we can interconnect them. So I'm going to take 2 more questions, if there are any, before
Somebody's asking about the YouTube link, but they can search Delmi Training Institute on YouTube.
Oh, yes. So what you can do is you can go here. .com, and whilst you're there, you can see all the links to our channels, YouTube, Instagram, TikTok, whatever. You can find all that, and it's got a lot of information as well. But most of the time, our handles are at Delmi Training. And then our WhatsApp number is 647, so it's +1. Okay, let me write that again. It's +1 647. What was it again? 647 446 0507. Yes. So 647 446 0507. You can catch us on WhatsApp here, and then we'll be glad. But this is our handle on social media. But you go here, if you cannot find it, just go to delmitraining.com. You find all our links. And so it's a good thing you can go there and you can also find. So one more question, if there's any.
I think that's it.
Okay, so I want to thank each and every one of you for watching. I hope you found this informative. Share our links. Invite your friend to be part of it. And that way they can also learn. I want to thank you all. My name is Roland. I'll see you on the next one.
Let's show this for a while, yeah. They can.
Oh, so we'll leave this one. Okay, that's good. Yeah, I have the microphones. Thank you, Ashwin.